What is up, guys? Welcome back to another video, and in this video we're going to be continuing on with our SwiftUI tutorial series, and in this particular tutorial we are going to be taking a look at how we can use NSViewControllerRepresentable to wrap a NSViewController subclass into a SwiftUI view. Now, why is this useful? Well, this is useful particularly if you have a already existing AppKit application that you are slowly but surely moving over to AppKit, or rather that you're moving over to SwiftUI, right? And you need to, like, your SwiftUI application doesn't have a screen or set of controls that your AppKit view controller does have, with a native SwiftUI implementation. So you can use a NSViewController subclass inside of your SwiftUI applications to achieve what you need to achieve in your applications. And then as features become available, you can start slowly moving them over to native SwiftUI. This is also useful if you have a control in your existing AppKit view controller, your NSViewController subclass, that isn't that while there is a native solution in SwiftUI, perhaps it's not quite as performant as it should be, and it wouldn't make sense to just shuck the entire view controller in favor of putting everything else into SwiftUI except for that one control. So there are many different instances where this is useful. Now, how exactly do we use it? Well, in my application in Xcode right now, so I have in my content view, I have two state variables, one for presenting a sheet, and then the other for selecting a color. Inside of our body, we have a Z stack that contains a color that will take up the entirety of the window. And then we have a button that summons our sheet. In the sheet, we have a color selector view. Now, this is not a native SwiftUI view. This is going to be a SwiftUI view that conforms to NSViewControllerRepresentable to wrap an NSViewController subclass in a SwiftUI view. Now let's take a look at what that view controller looks like, and I'll go over what exactly it does, because you may or may not be familiar with AppKit as of right now. So I'll kind of explain to you some of the basic concepts that this view controller is using that you will need to understand going forward. So we want color selector view controller. Inside of this file, let's go through this line by line. So the first thing that we're doing is we're importing Cocoa. Cocoa is the framework that contains AppKit, Foundation, all the necessary stuff to build a macOS application using AppKit and all of its related frameworks. This is the framework that we used to have to use explicitly when building macOS applications before SwiftUI came along. Cocoa has been around for a very long time. Over 20 years, this thing's been around. Then we're importing SwiftUI because we're using the SwiftUI color type inside of this view controller. So we'll have to import SwiftUI for that. Next, we have a protocol. This protocol is going to act as a delegate protocol that we conform to in what's called a coordinator. And we'll talk a little bit more about what a coordinator is as we move forward. But we have one method inside of this protocol that is required for any conforming class to implement. And that in this method will get run every time a color gets selected in the NS segmented control in the center of this view controller. Now, speaking of that, we reach the top of our view controller. This is, as you can see here, an NSViewController subclass. And then inside of our view controller, we have an NS segmented control. This is the same thing as using a SwiftUI picker with the segmented picker style. And then we have a weak var called delegate, which is going to be any class instance where the class conforms to our custom protocol. Now, we're doing this in particular to use a concept called delegation. Now, what is delegation? Well, delegation is the way for various objects to communicate with each other when something happens in an AppKit application. Now, it's not an Apple-specific pattern, but that's just how it works on the Apple platforms. You can think of delegation like a boss-intern analogy, where this view controller is the boss. It doesn't care how its delegate methods that it needs to call are performed. It just cares that the work gets done. The intern is the class that conforms to the delegate and then performs those tasks when asked. All right, so that's how delegation works. You're delegating work to another object. And one thing I should also mention before we move on is that we made this weak because we want to avoid strong reference cycles with our delegate. Because if there are strong reference cycles, it is entirely possible that we can't deallocate the controller or the delegate or both. And we want to be able to do that to avoid memory leaks and all that sort of stuff. Then we have a property called selected color. This is going to store the selected color for our controller, and we will be manipulating this as necessary in our NSViewControllerRepresentable struct. Then we have an initializer. This initializer takes in one parameter, and that is the selected color that we want to start out with. And then we are initializing our segmented control. So we have red, green, blue, cyan, yellow, and magenta as its color options, or its labels. All right. And then we have the tracking mode for our segmented controller set to select one, so we can only select one option at a time, as if it was a radio button. Now we're setting the target to nil, because we don't necessarily need a target at the moment. And then we are setting the action to a selector. Now, what is a selector? Well, a selector is a relic of Objective-C and Swift interoperability to make a lot of what AppKit does work. A selector basically is a method that communicates with Objective-C to perform an action. Now, the target goes along with that by saying, okay, this is the object the action needs to be targeted at. This is the object that performs the action, or should have the right method to perform the action. Now, because it's nil, it'll just use the current, and it'll use the next object that can support it. In this case, it'll be this view controller. Now we're initializing our selected color property here. And then we're calling the super initializer, setting the nib and the bundle to nil. That way our app doesn't crash trying to find a nib file for our view controller. And then for our view controllers, we are required to have a initializer with an NS coder. This is used specifically for storyboards, something we're not using, so we just have the app crash if this initializer gets called for whatever reason. Now we're overriding viewDidLoad. viewDidLoad is a view controller lifecycle method that gets run, as the name implies, when the view of the view controller gets loaded. So once it's loaded, this method gets called. Now the view of a view controller is pretty much the content that the view controller displays to the user. Inside of viewDidLoad, we simply call the super version of the method. So anything the NSViewController class does, our subclass will also do. And then we call a custom configure method where we configure various parts of the controller's UI. This is a custom method. So next we move on to our private function called configure. Inside of here we set the various properties of our segmented control. So we're setting the selected segment to an index based on the selected color. Now the value method is a custom method, again, that we will be using as we move forward here. We're setting the different segment style to separated, so they are still one control, but they're not touching. There's a little bit of space between the different segments. And then we're setting the selected segment bezel color to a teal type color. And then we're enabling programmatic constraints. And then we're adding our segmented control to the view of the view controller. Now, if you're not familiar with AppKit, the idea of constraints might seem odd to you. That might be a new concept. And pretty much constraints allow us in AppKit code to lay out our user interface controls. In SwiftUI, it does all of the constraining for you under the hood, so you don't have to worry about it. But in AppKit and UIKit, you do have to worry about your constraints. So that's something that AppKit and UIKit requires that you have at least a basic knowledge of how to do. Now, if you want to learn more about how constraints actually works, how view controllers and views in AppKit and UIKit work, I have 2 other series of videos that are currently ongoing as we speak on AppKit and UIKit respectively, so you can get up to speed on some of the basics of how this stuff works. Now here, NSLayoutConstraint.activate, we're simply laying out our segmented control, and all we're doing is we're just setting it in the center of our view controller and making sure that the width of the control spans the entire width of the controller, or the entire width of the controller's view, I should say, right? So that way, regardless of what frame we give our SwiftUI view, the segmented control will always be as wide as the view. All right. Now we're moving on to our func called value that takes in a color. In this method, we're simply switching over the color, and then based on the color, so NS color, system red, system green, system blue, system yellow, system cyan, and magenta, we return a given index from 0 to 5. And then if it's anything other than what we've specified, we return a negative number. Now, color value changed. This is the method that we specified for our selector. But there's one thing that you should note here, and that is the objc annotation. That annotation is what allows this method to communicate with Objective-C. So Objective-C will be able to see this method and call it whenever it needs it. Inside of this method, all we're doing is we're getting the selected segment of the segmented control that calls this method when its value changes. And then we are switching over that selected segment. And then based on the selected index, we are calling our delegate method by passing it this view controller itself, because that's the first parameter, and then the specific color that we want to use to notify our any class that conforms to the delegate what color was selected whenever it's selected. Right? So everything from system red, green, blue, system yellow, all that stuff, that's being done here. And then if it's anything other than index 0 through 5, we say, hey, just use clear as the color. And that's it. That's our view controller. Now we need to actually wrap this thing in a SwiftUI view. So what we're going to do is we're going to create a new file. I'm going to make this a Swift file. And this file is going to be called color selector view. Now, inside of this file, instead of importing foundation, we are going to import SwiftUI, and then we're going to create a struct, and this struct is going to be called color selector view, and we want to conform to NSViewControllerRepresentable, like that. And now we begin the process of wrapping our view controller in a view for SwiftUI. The first thing that we need to do is we need to implement the necessary methods from the protocol. There are 3 that we're going to use, and that is, first, make NSViewController. That is the method that is going to actually create the instance of our view controller and return it to the SwiftUI view so it knows what to render. Second is update UI view controller. Any updates to the view controller itself should be performed in this method. No state updates, though. Do not update state in this method because you will get unexpected behavior. And then third, we're going to use the make coordinator method. And once we reach the point where we are going to create a coordinator, I will explain what a coordinator is. Now, let's go ahead and get started here. I'm going to make room for properties at the top, and then we'll say make NSViewController. And then instead of returning some NSViewController, we want to return color selector view controller, like that. Now that we've changed that, all of the other methods will look at that and say, oh, okay, instead of some NSViewController, we need color selector view controller as either a return type or a parameter. So we'll say next, update NSViewController, like that. There we go. And then make coordinator. And then instead of returning a void type here, we will return coordinator, like that. Now, we haven't created a coordinator type yet, so we will get some errors, and that's fine. For now, let's go ahead and go into our make NSViewController. And above that method, we can specify a couple things. Now, if we go back to our content view, where we're inserting our color selector view in the sheet, you can see it only takes in one parameter, and that is a binding to a color. So what we want to do is we want a binding to a variable called selection. This will be of type color. And then we will have an initializer with selection binding color, like that. And inside of our initializer, we will say self dot underscore SELF, so self dot underscore selection equals selection, like that. All right, that is our binding and our initializer complete. Now that we have that complete, inside of our make NSViewController method, we'll say let color selector equals color selector view controller. And we'll pass in selection as the selected color, just like that. Next, we'll say color selector dot. And the thing that we want to use here is we want to set the delegate. So the delegate will set equal to self, and then we'll say color selector dot color picker dot selected segment is equal to color selector dot value for selection. That way we know. Now this should technically this may or may not be required depending on how you have your view controller's initializer. I'm just doing it here anyway, even if it might not be necessary, just to make sure that we do set the initial selection of our segmented control. Next, we want to return color selector. So now our view knows that we want to use our color selector view controller for its view content. Next, we need to update the UI view controller whenever the state changes. So whenever the state changes, this method will get called. Or whenever we have a modifier, whenever that modifier gets called, update NSViewController also will get called. So we need to make sure that our view controller is in sync with our state. And for that, we can say let index, we'll say, equals NSViewController.value for selection, and then NSViewController.colorPicker.selected segment equals index, like that. And that's all we need to do for our update UI view controller method. Because the segmented control is the only thing we really need to make sure is in sync with our state. That's all we need to do. It's as simple as those two lines. It could be a single liner, but we turn this into a two-liner just to make our code less repetitive. All right. Next is make coordinator. And while we don't have a coordinator yet, what we want to return here is return coordinator and pass it self. Now, the reason why we need to pass it an instance of this current view is because inside of our coordinator, we need to be able to access that binding to update the state whenever necessary. Now, with that, let's talk about what a coordinator is. Well, a coordinator is an object that will allow us to communicate back and forth between our AppKit view controller or delegates or whatever the case might be with the SwiftUI view. It'll coordinate different things, including state changes and all that sort of stuff. That's why it's called a coordinator. There is a much more in-depth technical explanation that could be had, but that is the bare bones just overview of what exactly a coordinator is. Now, the big reason why in this instance we're going to need a coordinator is because we need some kind of reference type object to conform to our custom protocol. And so the coordinator is the perfect place for that. Inside of our view here, before our binding, I'm going to create a class called coordinator. And then we're going to have this conform to color selector picker, or color selector view controller delegate. All right. Once we have that protocol conformance in our class definition, we need to do a couple things. First, we need a property called parent of type color selector view. And then we need an initializer that takes in a color selector view and then initialize the parent property inside of that initializer. So we can do that by saying var parent colon color selector view init underscore parent color selector view self dot parent equals parent. And then finally, we need to actually fulfill the requirements set forth by our custom protocol by providing an implementation for its only method. So we'll say we want our color selector view controller selected color. All right. And then what we're going to do here is simply put, we will say parent dot selection equals color selector view controller dot value for, or rather dot selected color, like that. Or we can just do we can just say equals selected color, like that. And then wrap this in a color object, NSColor color, like that. There we go. All right, so I want to make sure that this, okay, so what we want, to fix this error that we have, instead of color selector dot delegate equals self, we want context dot coordinator. There we go. And we should be good to go. Now, we'll save this, and we can run our code now. We have a successful build, and here is our application as it stands at the moment. We have a red background because that is the initial color. We can show our sheet here. Here's our sheet. We can see that red is currently selected. But let's change it to say blue. And now our window is blue. We can again change the value to say yellow. Now the background is yellow. And you get the idea from there. So that pretty much does it for how we can embed AppKit NSViewController subclasses into SwiftUI views. Thank you all so very much for watching, and we'll see you in the next video.